Okay, so algebraic proof. Before we get into the algebraic proof, we need to just check that we remember what we're doing with our sort of basic algebra. So here are a few questions for you to do, like expand and simplify, fully simplify and factorize the bottom one there. I want you to pause the video, work on a bit of pen and paper, or pencil and paper, I don't care, and then unpause the video when you're done. Okay, we've unpaused. Right, okay, so we've got two brackets here, like double brackets basically, and we're going to expand and simplify. So you could use FOIL or do what I do, which is FOIL, but I just usually put the lines in. So first of all, let's do m times m, which is m squared. And then outers, so that's m times by negative n. Well, that'll be negative mn or nm, doesn't matter which way round. Then we'll do inners, so n times n, and they're both positive, so this will be positive. Again, you could put nm. I'm going to keep it the same as this one, so it's just a bit more obvious. And L for lasts, n times negative n, while positive times a negative, so it's negative, and n times n is n squared. That's the expand bit, and then it wants you to simplify. Now, this negative mn and this positive mn will cancel each other out to leave m squared, take away n squared. Next one, x plus y all squared. Now remember, if you've got a bracket and it's squared, well, anything squared is just times itself. So you're going to multiply this out. Now when you multiply it out, you should get x squared plus yx, or xy, doesn't matter which way round, and you get another one of those, and you get y times y, which is y squared. But your final answer should be something like x squared plus 2 yx or xy, it doesn't matter which way round they are, as long as the number's at the front. And then, of course, y squared on the end. And this one, so 2n minus 1, 2n plus 1. Well, if we're doing FOIL, we do 2n times 2n, so that's 4n squared. We do outers, so 2n times the 1, so that's just 2n. Then we've got negative 1 times 2n, so let's take away 2n. And negative 1 times positive 1 is negative 1. And when you simplify that, those two middle bits cancel out to leave 4n squared, take away 1. And what about x plus 1 plus x plus 2 plus x plus 3? Well, notice there's nothing multiplied here. Actually, the brackets are kind of pointless. So essentially all you need to do is add together all your x's. Add together all those numbers, which is 6. And there we go, just 3n plus 6. Now factorize. Now notice there's an x and a y, so none of them, not all, sorry, let's try that again. All three of them don't have x, just one of them. All three of them don't have y, just one of them. The only thing that we can do here really as a factor is all three of the numbers will divide by 5. So we can take that outside of the bracket, and inside we shall have x plus 2y plus 5 on the end. And if we multiply that out, we would get 5x plus 10y plus 25. Okay, so just a little bit of algebra practice there. Let's get into the proof. First of all, let's just have a couple of thoughts about what on earth proof is all about. So what is proof? Well, is it Sherlock Holmes? Is it some evidence? Is it a magnifying glass? Let's see. Sherlock Holmes said this. Well, he didn't say this. Arthur Conan Doyle wrote this down in the books of Sherlock Holmes, that when you've eliminated the impossible, whatever remains, however improbable, must be the truth. And I think actually that sums up proof rather well. But if you're in the dictionary, it would say something like this: logical, mathematical arguments used to show the truth of a mathematical statement. We are trying to prove something, try to show that something is either true or not true. And in maths, proof means proof, not probably, right? You could say that you've got proof that the Earth is flat. I mean, we probably have to have a serious conversation afterwards, but because it really isn't flat. But in maths, proof means proof, right? You have to completely prove it. And I know that sounds kind of obvious, but we don't go on opinions. If you prove 99 million times that something works, well, what about the time after that might not work? You have to show that it definitely is true or not true. And we have three main types of proof. We have proof by exhaustion, we have algebraic proof, and we have something called a counterexample as well. So let's have a little look at those three. Sorry, this first bit is a bit of me talking, all right, because there's a lot of kind of information here to take in. Right, three main types. Proof by exhaustion. Now this one is that basically you show every example works. So you would just do lots of examples until you've done every example that could possibly happen. There aren't many times that you can use proof by exhaustion, because generally there are an infinite amount of numbers that you could use for something, which means you need an infinite amount of examples, which means you're never going to finish. So it's unusual to use proof by exhaustion, unless you've just got a limited set of numbers to work with, maybe. Now, algebraic proof is the one we're going to use most of the time, and this is just using algebra pretty much instead of numbers to represent, like, essentially any number, to show that some bit of maths will always work. Now, counterexample is an interesting one. This is where you show that something doesn't work. And in this case, you only need one counterexample to disprove something. A counterexample is all about disproving something, showing that it doesn't work. And you literally just need to show it doesn't work once, and then that's good enough. Because in maths, as I say, proof is proof. If you show that it doesn't work once, well, that's it. You've broken the rule. We don't have a rule that works 99 times out of 100. We just have rules that are either true or not true. Okay, but as I say, algebraic proof is the one that we're going to work on today, which is convenient because that's what the title is. See? Title. So let's go. Right, first of all, some useful keywords. All right, we're going to need some keywords. Check what we know what these are, because these come up a lot in questions. So integer, hopefully you've already met the word integer, and it just means a whole number. So, that could be 1, 2, it could be 13, it could be 676, whatever that is, 676, etc. Right? It's just going to be any whole number. Consecutive. So following each other continuously, right? So for example, it might say consecutive integers. Well, consecutive integers are integers that are next to each other. So whole numbers that follow on from each other. So 3, 4, and 5 are consecutive integers. So they're, they follow each other on continuously with no gaps. Sum. Well, you would have met sum probably back in your primary school days. It's just another word for adding something together. So if you've got the sum of two things, it means add them. Product is another word for multiplying. Used a lot in the USA. They use product quite often instead of multiplying. We talk about timesing things or multiplying things generally in the UK. And difference. You would have met that in primary school as well, but we tend not to use it so much in secondary school. But it's basically, if you see difference, it means you've got to subtract. The difference between two numbers means subtract one from the other and see what the answer is, see how far apart they are. Okay, now those are useful, right? So I'm going to put them up in the top right there just so you've got something to refer to if you see those keywords in a question. Now, every question is different, right? I can't emphasize that enough. Just about every question is different. So that's why algebraic proof can be a bit tough for some people, because there isn't an exact pattern to follow. It's not like, the useful things like KFC, keep, flip, change for dividing fractions, or FOIL for expanding double brackets. Every question is different. But the thing is, they have similar elements, right? They have similar little, well, basically little kind of building blocks that we can build together to help make the proof. Hey, little graphic. Yeah, I can feel you cringing right now. Okay, so let's have a little look at those elements. As I say, a lot of this is talking. It's a lot of you taking in. You might want to write some notes as we go along. Right, firstly, a number. If I need to show a number, usually an integer. Now, from now on, most of this what I'm talking about, I'm just going to say a number. I mean an integer, right? A whole number. And in this case, so if I'm saying a number, an integer, we'd usually use a letter. Quite often in proof, we like using the letter n. Now, in theory, you can use anything you like, but you'll find a lot of algebraic proof questions sort of kind of have n in them, or sometimes x, but usually n. Consecutive numbers then. So we're going to start with n, because that would be the first number. Now, if I want to then do the next number along, remember consecutive would be like 3, 4, and 5. Well, I would just add 1 to it, yeah? Just add 1 each time. So n would be the first number, n plus 1 would be the second one, n plus 2 would be the third one, and so on. And I could make as many of those as I like. So they are consecutive numbers. An even number. Well, what is an even number? Well, all even numbers have one thing in common. They can be divisible by 2. You know, they can be divided by 2. So basically, if we multiply something by 2, it must be an even number. So, for example, if n is any number, if I do 2n, that would be an even number. Okay? An odd number. Now, an odd number is a little bit trickier. It's kind of harder to pin down. Even's nice and easy. It's just times it by 2. But an odd number is a bit harder. So think of this. Think of how numbers go. Now, they go even, odd, even, odd, even, odd. You know that they are alternate as they go along. You get an even, then an odd, then an even, then an odd, then an even, then an odd, and so on, right? So if we've already got an even number, which I have, haven't I? I've got 2n. There's my even number. Well, the next one along is odd. So what I actually do is I do something one more or possibly less than an even number. So you might go 2n, that's an even number. If I add 1 to it, I get to an odd number, right? Because there's an even number. The next one along is going to be odd. Or possibly, this also works as well. We could do 2n, take away 1. So if I was at an even number, take 1 away, I get to the odd number before it. Now, it doesn't have to be plus 1 or minus 1. Plus anything that gets it to being an odd number. I could do 2n plus 3, you know, 2n plus 3. Start at an even number, jump 3 along from it. 1, 2, 3. I get to an odd number, yeah? Nearly there. And then we can do some questions. Right, consecutive even numbers. Now, start with one even number. Now, if I want the next even number along, I'm going to need to do 2 jumps, right? Because there's my even number, 2n. The next even number is 2 along. So I'm going to do 2n plus 2. The next one along from that is 2 more from there. So actually, from my original number, it's actually 4 along. So there's 2n. That one would be 2n plus 2. And then jump 4 to get 2n plus 4 to that next one. Okay, consecutive even numbers. And I can do the same with odd numbers as well. I'm going to start with, say, 2n plus 1. Again, to get to the next odd number, I need to do 2 jumps along. So 2 jumps along from this number would be 2 more. So it's 2n plus 3. And then, of course, 2n plus 5, and so on. Okay? Now, those are your kind of basic building blocks of doing an algebraic proof question. So let's try and remember all those. Let's go and apply them to a couple of questions, because that's where it gets a bit more interesting. They're quite satisfying, these questions, when you get them right. Yeah? So here we go. Prove, right? Prove, that means use some algebra usually. That the sum, that means add together, of an odd number and an even number is odd. So just basically that says, in normal language, add together an odd number and even number and then show the answer's odd. So let's do that. Well, let's do an odd number. An odd number, remember we said, you make an even number and then move it along 1. That is an odd number. Then I want an even number, so 2n, and it says add them together. So I am literally just going to go add them together. 2n plus 1 plus 2n. Well, what do we get when we do that? 2n plus 2n makes 4n, and the 1 is, well, there's nothing to add to that, so I just put the 1. Right, what do we notice about this? What did the question ask us to do? It asked us to show that this was an odd number. Well, this bit here is even, and I can show you it's even, because actually, if I divide that by 2, like essentially, let's factorize it. Take 2 outside. Do we agree that if I multiply that, I get 4n? Well, this is 2 times something. This has got to be even, yeah? And then, of course, if I add 1 to it, I get to the next number across, which is odd. So this is odd. That is correct. Yeah, did that blow your mind? Or did you go, that's really easy, show me another one? It's very much a case of just do the algebra that it says. Whatever it says, just do it and then see what you get at the end. And just chuck something on, well, not chuck, carefully construct something on paper and see where it leads you to. But just pretty much do what it says. So prove, okay, algebra. Half the sum. So half the sum, so I've got to add something up and then halve it, divided by 2, right? So I'm going to add something up. 4 consecutive numbers is odd. So just 4 consecutive numbers. Now, this doesn't say 4 odd numbers or 4 even, just consecutives, right? So I've got n, that's my first number. The next number will just be 1 along from that, and then 1 along from that again, and then 1 along from that. And it says half the sum of these. So firstly, I need to add them. And whatever that sum is, I'm going to halve it. And I've got to show that's odd. So let's do that. Let's just add them, right? So n plus another n plus another n plus another n is 4n. And 1 plus 2 is 3. Plus another 3 is 6. But remember, we're halving all of this. So let's halve each bit. So 4n divided by 2 is 2n. 6 divided by 2 is 3. Right, well, this is, quite obviously, an odd number, isn't it? This first bit is even. And 3 jumps along from an even number is an odd number, right? Yeah, because there's an even number, odd number, even number, odd number. You know, so we've got 1, 2, 3 jumps. We've got to an odd number. It must be odd. Next question. Now, this time, I want you to sort of pause it and have a go. And then, you know, think, just literally get some stuff down, see what it says, and unpause when you're done. Go. Okay, we've unpaused then. So, prove that the product, now that means times. It says so over here, multiplying, so it's times, of an odd number and an even number is even. Well, let's write an odd number. That's 2n, say, plus 1. That's an odd number. And an even number would be 2n. Now, I need to multiply these together. Now, if I just write this, look, the 2n is only times the 1. Because by, you know, bib maths, bob maths, whatever you want to call it, I need to do the multiplying first and then the addition. I need to put this in a bracket so I know that I'm timesing all of this number by this. Now, 2n times 2n is 4n squared. And 2n times 1 is 2n. Okay. Right, there we go. Fair enough. Now, I need to show that this is even. Now, how do I show that something's even? Well, I need it to essentially factorize it. I need to show that it's 2 times something. Well, look, both of these numbers will divide by 2. I can factorize this. So 2 is on the outside of the bracket. And it doesn't matter what's on the inside of the bracket, because if I times it by 2, then it must be even. Yeah, hopefully you got that, or at least got part way. So the more you do these, the better you get. Right, prove that the sum of any 3 consecutive numbers is a multiple of 3. Now, for this kind of thing, it's very similar to if I want to show something's even, I need to show it's, you know, I can factorize it with 2. I can show that everything is times by 2. Well, in this case, if I can get some algebra and then factorize it, so 3 is on the outside of a bracket, so we've got 3, and then I've got a bracket with something in it, 3 times something must be a multiple of 3. So I just need to try and factorize it using the 3. Right, so let's do that. Prove that the sum, so that means add up, of any 3 consecutive numbers is a multiple of 3. Well, 3 consecutive numbers, that would be n, n plus 1, and n plus 2. And it says sum those, so let's add them together. So n plus n plus n is 3n. 1 plus 2 is 3. And then let's factorize it. I can divide both of these by 3 and put it on the outside of a bracket. And I'd have n. And then, of course, we'd have the plus 1 there. If I multiplied this out, I would have 3n plus 3. This shows that it must be a multiple of 3 because it is 3 times something. It doesn't matter what value n's got. This will be 3 times something, which makes it a multiple of 3. Remember, we're saying that n is an integer here. Okay, cool. Right, your turn. Prove that the sum of any 3 consecutive even numbers is a multiple of 6. Remember, you're going to be factorizing it. So 6 is on the outside of a bracket and everything else is on the inside. Okay, pause the video and unpause when you're done. Don't just give up. Have a go. At least get something down before you unpause. Right, we're unpaused. Let's do this. So prove that the sum, that means add up, Any 3 consecutive even numbers is a multiple of 3. So let's get 3 consecutive even numbers first of all. 2n, there's my first one. Now 2n, remember I can't do plus 1 because that'd be an odd number. I have to do 2 jumps, so it's the next even number. And then if I do 4 jumps from the original number, that would also be another even number. And they're consecutive. Even, next even, next even. It says sum, that means add up, so add them up. And let's see what we get. 2n plus 2n plus 2n is 6n. 2 plus 4 is 6. And look, we can see this factorizes nice and easily now. We'll take 6 outside the bracket, divide the other two things by 6, so it's n plus 1. And this must be a multiple of 6 because it is 6 times something. Doesn't matter what's in the bracket, it's 6 times that, which is a multiple of 6. Okay, let's move on. Another question. Right, pause the video, have a go, unpause when you're done. Okay, we've unpaused. Prove that the product of 2 consecutive odd numbers is odd. Product means times, doesn't it? It means multiply. 2 consecutive odd numbers. Well, let's make one odd number. So that's 2n plus 1. And let's make another odd number. That would be 2n plus 3, because I've got to go 2 jumps, haven't I, to get to the next one. Now I need to multiply these together. So let's put them in a bracket. And we've got double brackets here, which means we can multiply all of this number by all of this number. Let's FOIL it. So first, 2n times 2n is 4n squared. Outers, 2n times by 3 is 6n. Inners, 1 times by 2, 2n. And 1 times by 3 is 3. Right, okay, let's simplify this a little bit. 6n and 2n goes together to make 8n. And we've got 3 on the end. Right, but now I need to show something is odd. Now remember, that means show that something is basically even and then move it one step along. Either add 1 to it or 1 along, or however many jumps you need to get. Basically add an odd number to it and it's got to be odd. Now I can factorize this by taking 2 outside, so we can make this even, can't we? So 2, divide that by 2 and I get 2n squared. Divide 8n by 2 and I get 4n. So this bit is even, because it's 2 times something. And we've got 3 over here. Now remember, my numbers always go, even, odd, even, odd. So if this number is even, that means we're here. I do 3 jumps, 1, 2, 3. It means I end up at an odd number. So this must be an odd number. What do we got next? Okay, now, before you pause this, this says any odd number. Now, if it's any 2 odd numbers, these are not consecutive. I can't have 2n plus 1 and 2n plus 3. They are consecutive. What you are going to need to do is make 2 odd numbers. So use 2 different letters. Use n, and I want you to use m as well. So use n and m in your 2 odd numbers. Yep. Anyway, pause the video, off you go. Okay, unpaused. Right, as I said beforehand, if it says any, well, I'm going to make up one odd number. I need to make any odd number, any other odd number, right? So what I'm going to do is use this m. I'm going to use 2m plus 1, which is any other sort of random odd number. Now it says product, and that means times. So once again, I'm putting my double brackets in. And I'm going to multiply them out. Right, first, 2n times 2m will be 4nm. It's not n squared or m squared because it's just n times m. And then outers, 2n times by 1 is 2n. And then inners, 1 times 2m will be 2m. I know it's confusing with n and m, but those are generally the letters we use. It's not wrong if you used other letters, but just these are the ones we like to use. And then 1 times by 1, because we're multiplying, is 1. Right, so we simplify this. Well, we can't simplify it, but we can factorize it. Remember, and odd number is made up of making an even number and then shifting it along enough places to make it odd. Now, these three bits here will divide by 2. So I can factorize those. So 2nm plus n plus m. So all I've done is factorize these first three things and divide them all by 2, put it on the outside of a bracket. Now I've got 2 times something. This makes an odd number. And of course my plus 1 hasn't disappeared. So this must be odd, because the first bit's even, knock it along one place, we get to an odd number. Good. Right, we're nearly there, nearly there. Remember, this one says any again, so I want you to use 2 different letters. So, you know, maybe N and M. Pause the video and unpause when you're done. Here we go. Right, product, that means times, and I'm going to times together any 2 even numbers. Well, 2n is one even number, and 2m would be another even number, and I'm going to multiply those together because it said product, and that means times. 2n times 2m, well 2 times 2 is 4, and n times m is nm. I need to show that it's even. That means factorize it by 2, 2, n, m, and it's straightforward as that. That's all you need to do. 2 times any whole number is going to be an even number because it's divisible by 2. And that's it. Done. All right. Now, I think I've got one more here. Yay, they say. Oh, no, we've got 2 more. 2 more. This is great fun. Oh, I'm loving this. This is awesome. I love proof. All right, pause the video. This is a tricky one, as is the one after it. But that will be it, I promise. Okay? Right, so pause the video. Off you go. Right. Tricky, but I was interested to see, or hear of, ideally, how you coped with this. Now, prove that for any 2 numbers, the product of their difference and their sum is equal to the difference of their squares. So, any 2 numbers, that's going to be n and m. The product of their difference and their sum, right, difference and their sum. So, their sum would be adding them together. Their difference would be subtracting them. Now, you might have put your letters the other way around. I'm not sure why I put m and then n, but it doesn't matter. It will still work. That, I've got to show, is equal to the difference of their squares. Well, that means I square them, and I subtract one from the other. I've got to show that this side is equal to this side. How do I show that? Well, I just do it, right? So let's multiply out this bracket. FOIL. First, m times m is m squared. Outers. M times negative n is negative mn, or mn, doesn't matter which way round. Inners. N times m. Well, that's positive because they're both positive. And that's m n. And lasts, n times negative n is negative n squared. Well, does this equal this? Well, look, yes, because you add together, oh, sorry, you've got positive mn, negative mn, they cancel out, which just leaves m squared, take away n squared, which is, of course, equal to that because it's the same thing. Yeah, so their product is equal to the product of their difference and their sum, there's the difference in their sum, is equal to the difference of their squares. Now, don't despair if you didn't quite follow that question. It's a tricky question to turn into, you know, algebra, right? There's so many of these examples. I keep saying there's only one more. There might be an exam question after this. We'll see how we go. Okay, right. I'm just going to talk you through this one before we pause. Prove that if the difference of 2 numbers is 4, so that means if when you subtract them you get 4, then the difference of their squares is a multiple of 8. A lot going on, but think of the last question. Give it a go. Pause now and have a go. Right, unpause, and I bet you have fun with this one. Right, difference of 2 numbers is 4. That means if I have 2 numbers, so n and m, if I take one away from the other, I get 4. And it's saying, if that's true, then the difference of their squares is a multiple of 8. So what I want to do is go, if I do m squared, oh sorry, n squared, let's do it that way around, take away m squared, it equals, 8 times something. It's a multiple of 8. Okay, now if you haven't had a go yet, try this. Let's just rearrange this slightly. So n is the subject. Well, to do that, I've got to add m to both sides of my equation. So I get 4 plus m. Well, think about this thing here. Think about n squared, take away m squared. How about we substitute it? I now know what n is, so let's substitute that into this equation. N is equal to 4 plus m, right? So if I substitute n for 4 plus m, then maybe this works. If you didn't manage it before, pause now and have a go. See if you can get to this being a multiple of 8. Right, let's have a look. Let's multiply this out. Now, first of all, we need to multiply out this first bracket which we've squared. So let's FOIL this. Now you should have, when you FOILed this, you get 4 times 4, which is 16. You get 4 times m, which is 4m, and another 4m. And then m times m is m squared. And then we've still got the other negative m squared on the end. Let's simplify. So we've got 16 plus 4m is 8m. And then m squared, take away m squared, leaves nothing. This bottom bit definitely factorizes using 8. Because I can divide both of these things by 8. 16 divided by 8 is 2. And 8 divided by 8 is 1. So it just leaves m. If I multiply this out, I get 16 plus 8m. And this is a multiple of 8 because it's 8 times something. Right, so the tricky bit here was that I had to have this leap of imagination where I rearranged the formula so I had it in terms of n, or n in terms of m really, and substitute it into the equation. Okay, and doing that meant that I could just get on with some algebra. Now that is tough. Is it as tough as this one? That's the same question, so skip that. Is it as tough as this exam question? I don't know. I would love you to have a go at this exam question. It is not as hard as the last one. You just need to do some multiplying out and then show that you can show, factorize by 8. All right, so have a go. This is, I promise, this is the last one. It's the exam question. Have a go at this. It's worth 4 marks in exam, which is loads of marks. Unpause when you're done. Okay, we've unpaused. Let's do this then. So, firstly, let's expand m plus 6 squared. So that's m plus 6 times m plus 6. And we'll subtract from that whatever n plus 2 times n plus 2 is. Right, firstly, we get n squared. I would have 6n, another 6n, and 36 over here. And then over this side, n times n is n squared. I'd have one lot of 2n, I'd have another lot of 2n, and then 2 times 2 is 4. Hopefully you got that far. That's just some expanding out brackets. Do a little bit of tidying. So n squared. Now 6n plus 6n is 12n plus 36. And then I've still got n squared. 2n plus 2n is 4n. And then there's a plus 4 on the end here. Now, here's the important bit. Because this was subtract whatever the answer to this is, this all needs to be in a bracket. Because we're not just taking away the n squared, we're taking away whatever the answer to this is. Now, I haven't bothered putting the first bit in brackets. I could equally put it in brackets, but I don't really need to. All right, but just for neatness, I will. So, when we're subtracting this, it means I've got to take away all of these things. I've got my n squared plus 12n plus 36. And I'm going to take away, firstly, n squared. I'm taking away 4n, and I'm taking away 4. So all of them need to be taken away. Now, n squared, take away n squared, leaves nothing. 12n, take away 4n, leaves 8n. And 36, take away 4, is 32. I need to show it's a multiple of 8. So my final answer, I need to factorize by 8, which is n. Why did I put 3n there? That should be, let's just go back and change that. It's not 3n. That, as I'm pretty sure I said at the time, is 32. So n. Now 32 divided by 8 is 4. And look, it is a multiple of 8, and that is worth 4 marks. Yeah, all I did was some expanding brackets. Remember, this is the tricky bit. Remember that you're taking all of the answer for this away. So stick it in a bracket until you're ready to take them all away. And there's the end. Right, well done. That is a tough, heavy-going lesson. Go and have a cup of tea or coffee, or maybe just sit in a darkened room for a bit and think about anything but algebra. And I'll see you next time.